Welcome to the Section 1-1 podcast for biology, and let's begin. The section is called What is Science? And what we're going to talk about is there's several sections here. You'll see several parts of this section. You'll see that they're in dark blue on the top, and that could be a good start for you taking your notes. So first question we ask, and this is a key to the chapter, is what is the goal of science? And the goal of science is to investigate and understand the natural world, to explain events in the natural world, and to use those explanations to make useful predictions. And you're going to see in the following sections, we'll talk about each of those 3 points in talking about data and observations. We'll talk about inferences, and then we'll talk about hypotheses. So let's give a formal definition of science. It's an organized way of using evidence to learn about the natural world. But science also has a second meaning in that it's the body of knowledge that scientists have built up over years of using this process. So one, it's a way of doing something, and also it's the knowledge that you've accumulated from doing that process. So first thing, we're going to talk about the first part of the science is that it begins with an observation, and you're gathering informations about events and processes. And I like the last part there. It says in a careful, orderly way. We're not going to do it haphazardly. We're going to plan it, and we're going to be very careful how we do this. Now, these observations are called data or data, and there are two types. Quantitative data are expressed as numbers, and you can count or measure with like an instrument or just by, like I said, counting. And then qualitative data are descriptive, and you're looking at the characteristics of something, and it says there it can't easily be measured. It's very hard to measure, say, color. It can be done, but it's not that easy. So here's a little chart. It's a little fuzzy for you, but if you look, I have qualitative data, and you can see qualitative has to do with the quality of something in the red, and quantitative data has to do with the quantity. Some examples of qualitative is colors, texture, smell, taste. Does it taste bad? Some people might taste good. Quantitative measures often do with things you can actually put a number to, like speed and temperature. It's 83 degrees. It costs $5. There's 8 people there, members. And if you look at this oil painting down here as an example, you can see that you can talk about it. A lot of the times we talk about oil paintings in terms of quality and qualitative data, such as the color, how well it's painted, what is the scene about. Whereas you can also look at it quantitatively. You can measure the weight. You can look at the size of it. You can give it a cost to it, how much area it takes over. And those are all quantitative ways of doing it. Now let's talk about the next part, which is inferences. Inferences are basically in a logical interpretation or based on prior knowledge or experience. It's a conclusion that you make from your observations. If you look at this chart, let's make some which ones are observation, which ones are inferences. Well, if we see that an object is round and orange, that's an observation. But we can make an inference that if it's round and orange, then it's a basketball. Object C is black and white. That's an observation. We're looking at color. Object C is larger than object B. We could measure it, or we could put them next to each other and look at them. Object B is smooth. Once again, an observation. Object B is a table tennis ball. Well, we've seen table tennis balls before. We know that they're small. And we can make an inference that this is a table tennis ball because it's smooth and it's smaller than object C. And each object is used in a different sport. Well, we could see where they're being used. And we can also infer because they are different looking, they have different we made different observations about them, that they would be used in different sports. Now, a hypothesis is the third part of that first slide that we looked at. It's a proposed scientific explanation for a set of observations. It's different than a hypothesis. Hypothesis is a conclusion. An inference is a conclusion. A hypothesis is a prediction, and it's often in the form of an if-then statement. Hypothesis is, because it's a prediction, you can then test it and rule it out or confirm it. And you have to put it in such a way that it can be tested. You can't propose a hypothesis that can't be tested. How do we test a hypothesis? Well, we'll perform a controlled experiment. There's that careful way of observing, and we can gather new data. Now, other ways scientists work, you're going to do this in your lab period. You're going to work in groups, work in teams, and you're going to analyze, review, and critique each other's data and hypothesis. A data or hypothesis made by one scientist is often repeated by another scientist to confirm that that scientist's work was accurate. This is a review process, and because it's repeated and tested by other people, then we can make sure that the conclusions are valid. To be valid, a conclusion must be based on logical interpretation of reliable data. You can't just make things up. Science is an ongoing process. This is this is basically a summary of it, but this is the important part that I want. It's always changing. Just because somebody has made a conclusion, an inference from data, and a hypothesis has been tested, that doesn't mean that the understanding can be changed. A new test, a new hypothesis can be proposed, and it might alter our understanding. The idea of something such as evolution and climate change is constantly being tested, and our understanding of evolution and climate change is always changing. These are examples. You may hear it in the news often about new data on climate change now makes us think that the climate change is accelerating. That would be it would be changing. And it says good scientists are skeptics, which means that it doesn't mean you don't believe something. It means that you should test it and question it and really challenge the science behind it. Now, why is this important with human values? If you scientists recommend things based on their work, and often these things affect your life, including the society in which you live in. A lot of our everything in your daily life, such as the quality of your water, is based on testing that scientists did to decide how best to make your quality of your water. Economic considerations. Science just doesn't extend to the natural world. It also can affect the economic world. Spending on research on healthcare, for instance, is influenced by tests. If there's a promising breakthrough in the fight against cancer, then maybe more money will be poured into cancer research, and that money may not be put somewhere else. Laws. The science often determines whether a law is passed. What is safe for you? What is the best for our society in general? And often it's based on laws that often depend on what science has told us, and moral principles. We often can use science for moral principles. Just the discussion of science can often tell us what is moral and what is best for society. And from this, citizens then can decide what to do to the vote. Science can help us decide what kind of society we want. Now there's a section quiz here. I think we'll just go through to the section quiz, and I can put these up there, and you can work on leave them up there for a moment and then show you the answer, and you can stop and look. And that's the end of this section.